our next speaker also from the USGS is Wagner, and he's going to talk about a new study on water availability. So, on that, would you Chad?
Thank you. Okay, thank you for inviting me, Mike. Thank you for asking me to be here. So it's kind of exciting to get to kind of talk about this water availability study, given where we've been already today, and some of the things that we've talked about, the issues that have been brought up. It's very timely, and that we're fortunate enough to have this study that's beginning, right now, and will be going on for the next few years, to really look at water availability and trying to put some tools in the hands of the resource managers in this area, in this greater Wilmington, actually Myrtle Beach area, coastal communities, to be able to plot the course of how we're going to make sure that we have sustainable water resources moving into the future. So that's what this part of the session is going to be about. I'm just going to talk a little bit about this, this new study. It's through the National Water Census Program, and it's we're kind of calling it the Coastal Carolinas Water Availability Study, because it does include more than just the greater Wilmington area, but it actually goes down into the Myrtle Beach, Georgetown area too. So we're looking at these coastal, kind of this metropolitan area, one of the largest metropolitan areas on the coast in the kind of southeast area. And we've talked quite a bit about the population growth that's been going on and that's forecast to be going on in this area. So it's very timely. So what I want to first touch on real quickly is, what is the water census? All right, so what is this? This is kind of the driving force behind this study. So first of all, what is it? So it is a program that was initiated by Congress through what's called the Secure Water Act in 2009. And the goal of the program was really to get a good accounting of the water resources across the nation, so that not only do we know what we have currently, what water resources we have available, surface water, groundwater, but then also get an accounting, a really good accounting of how much water we're actually using across the nation in the different various sectors. So get those two and then kind of cross those two. So how much are we using? How much do we have available? Look at the population change forecast and where that population is actually going to go. Intersect those two and see, do we have a problem? Do we not? What areas do we have the problem? And then in those areas that we do have problems or conflicts, let's go ahead and develop some tools for the water managers to be able to use to help to look at what-if scenarios and really help to shape the course. Because some of the things that Nat mentioned in his talk today, some of those questions that he asked, so one of those questions he asked was, what if we increase our groundwater withdrawals? And to what point can we continue to do that where we're still sustainable? Great question. And so it's very difficult to answer those questions, especially looking out in the future 20, 30, 50 years, without having some tools to do that. Okay, we can make our estimations, and I think it was, maybe it was Dylan or someone said that, when you're sitting around, or the folks that were sitting around that room trying to make that plan, they all knew whatever they picked, whatever plan they were going to make was going to be wrong. But at least if we have some tools, we can look at the spectrum of how wrong we're going to be. And we're probably going to be in that spectrum somewhere, so we can know the bounds of our inaccuracies, right? So that's what we're going to try to do with these tools, is just to be able to provide this range of the what-if scenarios. And if this happens, we can be prepared for it. If this happens, we can be prepared for it. So, so the objectives of this National Water Census, which is a USGS program, is, does the nation have enough fresh water to meet both human and ecological needs? So we really haven't talked about that ecological piece today. I'll touch on it a little bit, but mostly we'll be talking about the societal needs. And then, is this water going to be present to meet the future needs? So that's the kind of the overarching goals of the Water Census program. And like I mentioned, one of the aspects of the Water Census program is to actually do a really good accounting of the water withdrawals across the nation. And so USGS has been doing this 5-year water use compilation, and this comes out in a report every 5 years. And unfortunately, the accounting of our water use, although it's such a critical piece of information, over the years has actually gotten poorer. So the amount of water that we're using is less accounted for than it used to be. The scale at which we account for our water use is smaller than is larger than it used to be. So we aren't able to get down and get these really good numbers that we, even in 1995, we were able to get water use information on watershed scale. Now we're lucky to get it at the county level. So we saw a trend going in the wrong direction. So this, the congressional appropriations for this water census was to try to right that ship and try to, and spend a lot more time and effort in accounting for how much water we are using. So I just wanted to give you a quick snapshot of the 2010 water withdrawal compilation that USGS put together. And just some numbers here. So you can see that thermoelectric is probably the biggest water user as far as withdrawals. But we know that thermoelectric is not a consumptive user very much. So a lot of that water is redirected back into the source. Okay, so it's a big number on the screen, but how much of that is actually consumptive use is a very small amount, a small percentage of that 45%. Irrigation is the second biggest user, and we know that is a very big consumptive user. A lot of evaporation that goes on, transpiration that goes on, and only a very small percent of the water that we put on our crops is actually used by the plant. So a lot of that is evaporative losses and are moved to other places and then rain down in those other places. And so this just gives you, an idea of a snapshot in 2010. What I thought was interesting, and I just wanted to kind of show y'all, is this is population and total withdrawals since 1950. So population is the white line, okay? So we see a steady increase since 1950 of U.S. population. The bars are the actual water use, the total water use in billion gallons per day for each of these 5-year compilations that USGS has put together. So what we're starting to see is even though population is increasing, we're starting to see a shift, a reduction in the water use. So we're starting to see folks really waking up and saying, we need to conserve this resource. It is finite. So the education is starting to kick in, I think. We're being able to be a little bit more efficient with the way even industrial, commercial operations are going. And so we're starting to see, and this is we're back down to water use that, levels of water use that we hadn't seen since the 70s, so in 2010. So we're embarking on the 2015 water use compilation right now, so it'll be interesting to see if that trend continues. Just some highlights, that total water withdrawals were 13% less than 2005, 2010. Population increased by 4%. And it's the largest percent decline in water withdrawals since we've maintained records. So it's the biggest decline since we've been maintaining records. And really there were decreases in all categories except aquaculture and mining, both of which we saw a small increase. So thought that would have been interesting. So I want to shift gears now and talk specifically about this study that's going to be going on in our area here in the Wilmington and Myrtle Beach areas. So as part of this National Water Census Program, they have something that is called these focused area studies. And they're really focused water availability assessments in particular areas where there is some water conflict or a soon-to-be water conflict. So these focus studies really bring a lot of different aspects to bear. So we're looking at water quality, we're looking at groundwater resources, we're looking at surface water precipitation trends. We're bringing ecological flows into the mix. So we're looking at, okay, how can we balance our water use that we can both make sure that society has enough water for our uses, but also the ecological needs are met as well. So bringing all of these aspects to bear in a study and providing the tools that the water resource managers need. Okay, so here's a kind of a snapshot of where these studies are in the landscape across the U.S. So we just finished the first cycle of these focus area studies, and the first cycle included Colorado River Basin, the Appalachia-Chattahoochee-Flint, the ACF, River Basin. I think many of you maybe have heard about those water wars, but there's quite a bit of conflict in that area. And then the final one that is just completing is this the Delaware River Basin, which is kind of in the northeast area. So the next round, which is just starting in 2016, is the Upper Rio Grande Red River Basin in our area, the Coastal Carolina Basin. So we had to submit proposals, and they were reviewed, and we were selected. These new three were selected to start this focus area study in 2016. And so we had to kind of make the case of why this area was worthy of having this study be done and being funded by this National Water Census Program. And so we were able to make the case. It wasn't that hard. Although a lot of these other areas have a longer history of water conflict, but I think the reviewers saw the growing, kind of the sleeping giant that was in this area. And then I heard a couple of them say that they felt like this area was the Delaware River Basin about 30 years ago. And so they were excited to be able to get kind of ahead of the game a little bit and do this study now before it's a little bit too late. How they're dealing with in the Delaware River Basin now, it's more reactive, and how can we just triage the situation? So it was, even though the conflict to the external community is not so great in this area, it was worthy to go ahead and try to do this study here and get ahead of the game. So that was kind of exciting. So here's our study area. Hopefully you can see that the green shaded area is the greater study area. So it really includes Georgetown all the way up to north of Wilmington to some of the Pender County area. And the reason for it, I think we've touched on a lot of the reasons today already, but there's in this coastal area, we've got a much tighter gradient of our communities, really, from where we've got that saltwater interface to where all the population is. It's a really tight gradient. So the population centers are really more tightly packed than you may have in a non-coastal area. So you've got a lot more pressure in a smaller amount of area. We've got the impact of hurricanes, natural disasters, droughts. We're having more frequent droughts in the southeast. We've talked about groundwater capacity use areas and the potentials. There already is a groundwater capacity use area in that South Carolina portion of the study area. And so we talked a little bit about that in this area as well. And then we've also got the whole sea level rise and climate change, land use change. Dylan talked about that this morning, about looking at what the land use change is going to be and where is population going to be expanding in what areas. And down in South Carolina, it's a little bit more of a salinity intrusion for surface water intakes. We don't really have that issue too much up in this area, but a lot of their surface water intakes in the Myrtle Beach area is actually in the intercoastal waterway. So as saltwater intrusion increases, sea level rise increases, and you've got less fresh water coming down from the mainland because of droughts, you've got that salt pushing back further and can intersect with their water withdrawals, and that's a problem. Those plants are not prepared to handle the salt water. So why? We've talked about it. Here's the legislation that we talked about earlier that specifically targets this area and the need for water availability study. And also what's pretty interesting is that we're starting to see indications that the 7Q10, which is a discharge parameter, a statistic, that a lot of regulation is built around. And it's that 7-day low flow period that has about a 10% annual exceedance. So basically it's 1 in every 10 years, statistically, that a 7-day period will have this particular low flow discharge. That is, we're starting to see indications that could be almost as half of what it has been historically at Cape Fear Lock 1. And that has major implications on the amount of water that we can withdraw from surface water. So as the climate changes, and so these statistical numbers can change based on flow data. And as flow data changes, we have droughts, we have more droughts, more extended droughts. These statistics change. And therefore, the permits that folks are relying on, also, it's very much tied to that. So, so we see that there's a, I don't think we're anyone in this room is unfamiliar with these issues, but they're real. So that's the emphasis of this project, is to try to help understand and be able to have the tools to predict what we're going to do. So what are we trying to do in this study? Objectives and scopes, we are trying to develop water use estimates and better water use estimates, have smaller watershed scales. We're going to try to develop surface water models to evaluate potential changes in water availability and salinity in response to different water use and climate change scenarios. Ecological response models to alterations in flows, so how the fish and vertebrates going to respond to less water or more salty water in certain areas. And then groundwater flow models of our aquifers. And one of the things that I was happy to see the land use change work that's going on is also part of this. We're working with NC State to do some land use and some land change modeling so that we can try to predict where these population centers are going to pop up in 2020, 2030, 40, 50, 60. And we can use these models to actually help us see how much water use different areas are going to have to be. So surface water modeling, I think I just touched on that. We're going to leverage a lot of work that's already been done in the Cape Fear River Basin. But we're going to develop a surface water model that can be used to estimate, really have different scenarios. Okay, let's say we withdraw this much water. How much is going to be left for societal or ecological uses? Let's say that we have this much reduction in precipitation in the upper Cape Fear Basin. Now how much water are we going to have available to us at Cape Fear at Lock 1? Okay, so we can run these scenarios and start to see what kind of impacts we're going to have. Ecological response modeling. So we can take the flow data from that surface water model and see how it's going to affect the ecology and the fishes in this area. And we can also look at different implementing different ecological flow standards and how implementing different standards, which is at a regulatory level, how that's going to impact the amount of water that's actually left in the river for the ecology. Okay? So that's another aspect of it. And then the final one is groundwater flow modeling. So this is going to be a major part of this study, and it's very important in this area. And it could help to answer some of those questions that Nat was talking about this morning. And we're going to leverage an existing groundwater model of this area, but refine it greatly, and also include a superficial aquifer, which is that unconfined right near the surface. We're going to include that in this model. And we can really create, with this groundwater model, we can create hypothetical scenarios that will be able to predict future water levels and salinity conditions in the aquifer. And it's not so much, I mean, it will be hypothetical scenarios, but it can be scenarios that the planning community are actually using when they're developing their long-range planning. And it also can drive some of those long-range plans as well. So this tool that they can use to actually do what-if scenarios, and what if we did this, how would this react? Or how, if we put water systems out into this part of the community, and now there was stress in this part of the community, what's it going to do to the aquifer levels? What's it going to do? Is it going to induce more salinity intrusion in different areas? And I think there's one piece I wanted to bring up to this group that's not directly part of this study, but it could really be leveraged basically because we're already developing this groundwater flow model, is we could, while we're at it, actually develop a saltwater intrusion groundwater model for this area or some specific communities, which actually would really provide that extra layer of information to look at, okay, if you withdraw this much water in this particular area, how much salt is going to be intruded into particular aquifers that we talked about. So even though it's not part of this study, I just want to let it be known that, you know, we can partner with some additional funding partners to make this a reality while this study is going on, and really leverage it and make it very efficient to do that. And I think it's a very important piece. So the modeling benefits of groundwater is, you know, it can help to manage the groundwater resources in the region. if we add that saltwater intrusion piece, we can look at what various scenarios of water withdrawals will contribute to salinity intrusion. And it'll allow water suppliers just to be proactive about their planning and how, and just make it more educated. And I think that would be very beneficial to them and the community if they've got some kind of tool that they can use to try to make more educated decisions. And so the expected results, we want to come up with better water use estimates at the watershed level for this area. We want to have a better accurate and more accurate assessment of the consumptive water use demands and the water availability in this area. And then developing tools and these water use scenarios. And we can have these tools that we can use, we can put in different water use scenarios and get some results, and then we can kind of get that range of uncertainty that we're going to be dealing with here. So I think hopefully these will be able to provide the water users and water producers and the water resource managers in this area a lot of tools to help make better decisions. So I think that's really it. I'm happy to take some questions. Thanks for giving me time.